So finally, the question is, what are irrational numbers? An irrational number would then have to be a number that has an infinite number of decimal places and no fixed repeating pattern. So what could be an example? Well, let's say I had a 2 followed by a 3. Then I took 2 2s and then a 3. Then I took 3 2s and a 3. Then I took 4 2s and a 3. Then I took 5 2s and a 3. And if I keep going on like this, you see the pattern does not repeat. At least, I mean, there is a pattern here. The issue is it's of varying length. The portion that repeats, right, it has a varying length and not a fixed length. So it's not a fixed pattern. The pattern is changing, you see. So when I'm dealing with something like this, there is no way to count it. Just no way to count it. And how so? Well, think of it this way. We understand that the set of real numbers is basically, we denote it with the symbol R with a vertical line across through it, right? So the set of real numbers is just is the set of all rational numbers and irrational numbers. We combine them both together and we call it the set of real numbers. Now, consider the real number line, right? If I have the real number line placed before you, and let's say here I have the number 0, here I have the number 1. And if I asked you, what's the next number after 0? Can you point me towards the next number after 0 on the number line, given that I'm considering every real number? Now, so here's the problem. Let's say you said 0.5, right? If you said 0.5, I would say, wait a minute, you're missing some numbers here. For an example, the number 0.25, which is half of what you said, falls between 0 and 0.5, your suggestion, right? And you missed it. Okay, then what if you suggest 0.25 instead? What if you told me, okay, fine, I choose 0.25. Let's say somewhere there we have 0.25. Then I will once again have this number and I'll tell you, wait, you missed 0.125. And I can do this forever. For any number that you throw at me as a challenge, I'm going to have it and it's going to fall in between. Like, here's your challenge, X, here's 0, and here's my response to you, which is X by 2. X by 2 will always fall in between 0 and X. So no matter what number you throw at me as a challenge, I can always find a number that you missed. So basically, there is no notion of what the next number is. Literally none. We can't find the next number. So that's the thing. You see, when I count things, I'm actually arranging them in a sequential order. Like when people stand at a line, you see, like let's say at a bank or perhaps at assembly at school, people stand in lines, right? So let's say we have a store maybe or a bank or an ATM booth. Let's say I have some kind of a booth. Everyone needs a service from this booth. Perhaps there's a telephone booth. It could be anything, right? So here's a guy standing at the front. He's the first person there. Then there's a second person. Then there's a third person and a fourth, so forth and so on. The point is, you arrange them in a sequential order. When I say first, I literally counted him. This is one, I counted the second guy as well. I counted the third guy, I counted the fourth guy. I associated a number with all of these guys. When I tried to count the number of people in the queue, I associated a number with them, and in essence, I arranged them in an order. And if I wanted to, let's say, I don't know, I'm partial towards the fourth guy. He's my best friend. So what did I do? Let's say I'm in charge of controlling the queue. I decided that I'm going to count you as 1, and then you as 3, you as. Let's say I'm free to count people in whatever order I wish. If so, I could have counted them in a different order, and I could have done something like this, counting the fourth guy as the first. However, that's up to me, and either way, this still creates a sequence, right? Now, in the sequence is such that this guy goes to the booth first, followed by this guy, followed by this guy, followed by this guy. So basically, it doesn't matter. I'll count in whatever way I please. I'll count in whatever way I please, and it will create an order. There is a sequence, and I can always, within the sequence, say that this is the first guy, this is the second guy, this is the third guy. Or perhaps in the previous example, here 0 is the first guy, -1 is the second guy, 1, +1 is the third guy. Counting always creates a sequential order. If there is no sequential order in the first place, if there's no way that I can, like, let's say, arrange the numbers, like as I've expressed before, you just can't point towards a number that you can claim to be the next number after 0 on the real number line. You can't. So that's the problem. I can't count it. But what's a nicer way to explain this concept?